Hello and welcome to our final presentation. Here we were able to do the G1 Blue Tram for EGR 305 class. My name is Jessica Caicedo.
I'm Derek Watson.
And I'm Juan Villalta.
So here we have the final assembly of our tram. Here is a rendering model. We have the bogie assembly. We have two bogie assemblies down here with the wheels. We have the pantograph sub-assembly up here. We have the track, which we'll be later implementing in our kinematics simulation. We also have the doors here open just to better see the interior, and they will also be closing and opening in our kinematics. We have some air vents up here just to make our tram more realistic. Here we have the cross-sectional view of our tram, and this was done just to better see the internal structure. Here we can better see how the bogie was made with the wheels and the axles. Here we have the single chairs and the double chairs. Here we have some steps for our passengers, as well as some poles which you cannot see very well right here. And then here we have the steering wheel as well.
So the overview of the project was developed with team dynamics, where we're going to discuss how we tackle our problems. Next, we're going to have the aforementioned sub-assemblies, where we discuss how the assemblies are composed, their materials, and their problems that we encounter. Then we're going to see our kinematics. We're going to fly through the cabin, and we're going to state our conclusions.
So for the team dynamics, the first thing we wanted to do is make sure we complete our parts and drawings as quickly as possible. We actually have the schematics for our tram from online, so we wanted to make sure we saw how many parts there were, and we divided everything up, make sure we'll beat that as soon as possible, because there are so many parts here. We used our communication was basically a group chat. We updated each other regularly about some of the issues we're having, some of the problems that we ran into, and asked each other for advice on ways to solve that. In that manner, there were no leader roles. Nobody was at the captain of the helmet, or everybody kind of just did their own part and helped each other out as much as possible. So the parts were distributed by the drawing sheets. We went our separate ways in a manner, did our parts, came together, put it all together. So the very first sub-assembly is mine. It is the bogie sub-assembly. All of the pieces you see are actually made of steel, irrespective of their color. The color is simply due to the fact that that's what it was presented to us as in the schematics. So the upper left portion is the bogie frame. This portion is supposed to be symmetric about the vertical axis. However, due to some rounding in the schematics, we ran into some problems actually making it. So the part actually isn't as symmetric as it's supposed to be. There's slight deviations. The bottom left is the wheel and axle portion. It's a very basic sub-assembly. And together you have two frames, two wheel axles, and a pivot beam as well. The hardest portion about this was the bogie skirting at the very bottom here. This portion was actually angled in two directions, and the schematics didn't actually give those angles. So I had to make it based on another part right here. In order to go into the assembly and actually make the part, I had to use the faces of another part in order to make everything right. Most of this was made in part design, simply because the portions I have were going to have the kinematics applied to them. I decided to save the complexity for the later portion of the project and make sure everything looked right. So the bogie frame right here for the angled portion was made in GSD mostly, but I mostly used part design for everything else.
So now we'll be talking about sub-assembly 2. Here we have the internal structure sub-assembly. This is the base of the tram as well as the chair layout. Here we have the fuel tanks, which are located on the bottom, which you cannot see very well due to the steps placed here. The chair layout was placed so that the passengers can have space when they're going up and down the aisle. We have some poles placed here for convenience as well. The base of the tram was made through GSD. However, there was some conflict when doing the dimensions since the sheets were not very clear. Therefore, I had to rely on other parts on their dimensions to make sure that when putting the assembly together, everything would fit well. But overall, the base was able to match very well, and it was able to fit in the assembly.
So the sub-assembly 3 was basically the cover of the tram. I had some difficulties making this part because some of the dimensions didn't show up, especially for the roof. Yeah, you can see these kind of like curvatures right here, and then this side right here. I had to rely on other views, and also I had to eyeball it using GSD and kind of mirror this part to that part so it can be symmetric. When doing the cover, I had some difficulties using the windows dimensions because they weren't there, but I rely on other windows so I can make this kind of all the window patterns. Basically, I also did the features on the top, which is the capacitor, the sign, and the air vents. Putting it together was kind of hard because this part right here is rounded, so I had to come up with ways to actually constrain the parts to do the assembly.
So the last assembly was also mine. It was the pantograph assembly. We originally weren't going to do this one simply because we thought that we wouldn't have the time, but as we were doing our part, we realized that hey, it's feasible to actually get this one completed. So it's made up of two major sub-assemblies, the top and the bottom. One of the major issues for this is that the part is supposed to be symmetric, but the angles weren't given for deflections here, and the rounding caused some major errors in trying to align some of these holes. Overall, we decided that the best idea was to slightly move one hole here and here by 8 micrometers. Yes, 8 micrometers was the difference. So all of this assembly is made of steel again, and if you're curious about the purpose of a pantograph, it's actually a current collector. The tram is basically entirely electric, and so the pantograph's job is to collect current from a wiring system above it. The wiring system is not included in that in the diagram simply because it's beyond the scope of the project. So here we have the kinematics for our tram. As you will see, the doors close, the wheels turn, and the track goes through simulated motion. The wheels turning appear to be kind of strange simply because of the way it was captured by PowerPoint. I can assure you that they are turning in the right direction because we went through the painstaking process of making sure they were. Basically, everything here is in the bogie, everything is a revolute joint, and the doors are prismatic joints. And the prismatic joint is also applied to the track to make sure it moves.
So here we have a fly-in through the cabin. So as we see here, as we go through the internal structure, through the windows, we'll be able to see better the chair layout and how they're spacing for the passengers to go through. We have the poles, we have a step, and we have more chairs on the other side, as well as the steering wheel, and then we exit through the back.
So to conclude, the project was successfully done by our teammates. Did a great job. We finished it in a timely manner. Also, there was a good team dynamics. We communicate well. We keep in touch every week, keeping us updated. Any problems that we encounter, we talk to each other. Also, we explore different CATIA tools, the GSD, the kinematics. We went a little bit beyond on kinematics that we learned in class. We discussed how to do sequences for the doors and for the wheels. The only downside about this project was the unclear dimensions that led to assumptions for the assemblies, but overall the project came out really well and it fitted nicely when we put it together. And I just want to say thank you for the presentation and hearing us today.
Okay, thank you very much.
Thank you.